take another example. This time, the question is about a relation is being given. Secant theta minus tan theta equals p. A relation like this is given. The question is, find cos theta. If secant theta minus tan theta is p, the question is, what is the value of cos theta? Let's do one thing. Let's recall the relationship between secant theta and tan theta. We have the identity. Among the three identities what we discussed, we know that 1 plus tan square theta as secant square theta. So you have the secant square theta minus tan square theta as 1. Just bring this side, you get secant square theta minus tan square theta is 1. Let's not forget our good old algebraic relation. A square minus b square is what? A plus b into, instead of a it is secant theta, instead of b it is tan theta. A plus b into a square, a plus b into a minus b, secant theta minus tan theta. This all should be 1. Already you are given that secant theta minus tan theta is p. When secant theta minus tan theta is p, so secant theta plus tan theta should be equal to 1 upon p. When secant theta minus tan theta is p, secant theta plus tan theta has to be 1 by p, because p into 1 by p is 1. If this is p, this has to be 1 by p, then only we have this as 1. Sorry, if this is p, this has to be 1 by p, the product should be 1. Now we have these two relations. What are these two relations? We have secant theta plus tan theta as 1 upon p and secant theta minus tan theta as p. Now simply adding these two relations, we get 2 secant theta as, adding this we get p square plus 1 upon p. Therefore, you get secant theta as p square plus 1 by 2p. Let's recall, what is cos theta when you know secant theta? After all, secant theta and cos theta are reciprocals of each other. Therefore, you could write cos theta as how much? 2p by 1 plus p square. So let's run it quickly once again. You are given that secant theta minus tan theta is p, and you are asked to compute the value of cos theta. You are asked to find cos theta. The first step is to write 1 plus tan square theta as secant square theta. This is just a quick recap of the trigonometric identity. Then if you bring this tan square theta to this side, you get secant square theta minus tan square theta as 1. And let's also recall a square minus b square as a plus b into a minus b, where a is secant theta and b is tan theta. So secant theta plus tan theta into secant theta minus tan theta is given as 1. Whereas we have secant theta minus tan theta as p. And so this part is p. So this has to be 1 by p. So once it is 1 by p, we can write down these two equations. In fact, it looks like more like a simultaneous equation. So something like x plus y equal to 1 by p, x minus y equal to p. So what is x? On those lines we can solve this. We get 2 secant theta as p square plus 1 by p. So secant theta becomes p square plus 1 by 2p. Changing it you get 2p by 1 plus p square. So here we have a question. A man standing 50 meters away from the foot of the tower is observing the top of the tower, and he found the angle of elevation to be 60 degrees. He is standing at a distance 50 meters away from the tower and is observing the angle of elevation to be 60 degrees. The question is to find the height of this tower. So this is the tower, the man is standing here. Now you could see the ratio which connects h and d is tan theta. So tan 60 is how much? Opposite by, this is the tower, opposite by adjacent, h by 50. So what will h be? 50 times tan 60. Tan 60 we know the value as root 3. So 50 root 3 should be the height of this tower. Here we have a problem where there is a pole. The shadow of the pole is very much there on the ground, and it is given that the length of the shadow is d, the height of the pole is h. It is given that the length of the shadow is 1 by root 3 times that of h. Length of the shadow is 1 by root 3 times of h. And the question that we have to find is the angle of elevation of the sun. That means this angle is what we have to find. So again you can very clearly see that it is opposite by adjacent is what is tan theta. In fact, tan theta is h by d. You know that d is 1 by root 3 times h, or h by d would be root 3. Now we have tan theta as root 3. If tan theta is root 3, what will theta be? 60 degrees. So the angle of elevation of the sun is 60 degrees. Here we have a problem where a man is moving towards a tree. So let's look at this as tree. A man is moving towards a tree. Initially, the angle of elevation is 30 degrees. After walking 50 meters towards the tree, he again finds the angle of elevation to be 45 degrees. Earlier, the angle of elevation of 30 was 30 degrees. On moving 50 meters towards the tree, he found the angle of elevation to be 45 degrees. The question here is to find the height of the tree. So let us take this distance as some d, a dummy, let's say. You can see clearly two right angle triangles. There's one right angle triangle. Let us give some names for this as A, B. Let's take it as C, and let's look at this as C, and let's look at this as some D. So let's give names for this. Look at triangle ABD. Triangle ABD. Tan 30 in the triangle. Tan 30 is opposite by adjacent. So opposite is h by what is adjacent? This length 50 plus this length d is 50 plus d. Let's look at the other triangle, that is ACD. Triangle ACD. If you look at tan 45 is h by d. Opposite by adjacent. Let's not forget this. Tan 45 is h by d. From here you could see that 1 equals h by d, or d is same as h. Actually our interest is to find d. What is d is what is the question. So d is something which we created just as an intermediate step. We don't require to know this d. So in this relation, wherever there is d, we can plug h. So take this d as h, and you get h by 50 plus, instead of d we'll plug h. Tan 30 is 1 by root 3. So we've got everything in terms of h here. So we could write this root 3 h equals 50 plus h. Bring this h to this side, you get root 3 h minus h as 50, or h becomes, or we will write root 3 into h minus, sorry, we'll take pull out h into root 3 minus 1. We write it as 50, thereby you get h as 50 by root 3 minus 1. So that will be the height of the tower. 50 by root 3 minus 1 will be the height of the tower. Here we have a problem where a plane is flying at a height of 1000 meters or 1 kilometer, and a person is observing the plane at a certain instant. The angle of elevation is found to be 60 degrees. Well, subsequently what happened is, that is after 5 seconds, what has happened is the plane has moved to a different position. It has gone to a new position. Initially, let's say it was here, the plane was here, now it has moved to a new position. What has happened is, initially the angle was 60 degrees. Subsequently the plane moved, that is after 5 seconds, it has gone to a new position, that's what the problem says, and the angle of elevation this time is found to be 30 degrees. From 60 degrees, it became 30 degrees. The plane has gone to the new position. This is the position, the angle of elevation is 30. This is 1000 meters, or you can write 1 kilometer, whichever it is. See the interesting part in this question. We are using time and distance. What is the last word in the problem? Find the speed of the plane. You could see that speed is something which comes in the context of time and distance. So the philosophy of this problem, or the beauty of this problem, is all about linking time and distance with heights and distance. So we know heights and distance as one chapter in trigonometry, time and distance as a different chapter in your arithmetic. You could see how well these two can be related. That's what is the essence of this question. As usual, we could see two right angle triangles here. Let's take a look at the first right angle triangle. The first right angle triangle, you could see that tan 60, the full angle tan 60, initially it was 60 degrees. So tan 60 is how much? 1000. If you don't mind, we'll write it as 1. Later on, we'll change it to 1000 meters. So 1 by, let's take this as some x and this as some d. That's 1 by x. Then what is tan 30? Tan 30 is 1 by x plus d. Tan 30 is 1 by x plus d. Tan 60 being root 3, you can write x as 1 by root 3. You got the value of x. Because x has got no business, we actually have to find the distance. The idea is very simple. Once you know the distance and you also know the time taken, we can find the speed. What is speed? Distance by time. The distance is what we have to use. We have to find using heights and distance. Anyway, time is given in the question. It all amounts to finding the distance. Let us find this distance. Already we got x as 1 by root 3. So tan 30 is 1 by root 3. Let me write it for you. Tan 30 is 1 by root 3 is x plus d. Or x plus d is root 3. Whereby you get d as root 3 minus x. That is root 3 minus 1 by root 3. How much is this? 2 by root 3. This 2 by root 3 is kilometers. 2 by root 3 is kilometers. That is, in 5 seconds, it is able to cover 2 by root 3 kilometers. What is the question? The question is, we have to find the speed of the plane. So what is the formula for speed? Speed is distance by time. Distance being in kilometers, we'll write it in terms of meters as what? 1000 meters. So 2 by root 3 kilometers is 1000 by how many seconds it has taken? 5 seconds it has taken by 5. So this should be the speed of the plane. So 2 by this. So how much is this? You get it as 5 to 10. 200 into 2 is 400 by root 3. The speed will come as 400 by root 3. That should be the speed of the plane. Okay? Which unit? Meters per second. So thus we see how exactly heights and distance can be used to even measure the speed of the plane. Obviously, without going into air, you can still find the speed of the plane. That is the interesting thing about trigonometry. So this lecture has captured very, very fundamental things of trigonometry.